Okay, so this lesson, it's the vertical resistor motion part 2. So in this lesson, I'm just going to try 3 questions. And I just feel like these 3 questions are quite typical. You know, it's actually pretty good. It covers everything that you need to know for the vertical resistor motion. So let's just have a look at the first question here. Question 6. A particle mass 10 kilograms is found to experience a resistive force in newtons of 1/10 of the square of the velocity in meters per second while it's moving through air. Okay, so let's just, again, you can highlight or you can just label the important information. Mass is 10 kilograms here. We have a resistive force that's 1/10 of the square of the velocity. The particle is projected upwards, okay, vertically up. Find a point where the velocity of u meters per second, okay, at point O, so that's the starting point, that is the initial velocity. The point A vertically above O is the highest point. So A is the highest point reached by the particle before it starts to fall to the ground again. Assume that G is equal to 10 meters per second square. All right, so we have this question here. We have all the information we need. Okay, so let's just write down everything we have, all right? So M is equal to 10 kilograms. We know the resistive force here, or the resistive force is 1/10 of the square of the velocity. The square of the velocity. Okay, so in that case here, the resistive force is kV square, and then K is 1/10 of the square of its velocity. Okay, so and what else we know? Okay, so when t is equal to 0. The initial velocity is equals to u. The highest point is just equal to a. Okay, and we also know that g is equal to 10. So that's all we know, okay, from the information provided to us. Now, let's have a look at the question. Show the particle takes this amount of time to reach from A to O. Okay, from A to O means to reach A from O. So we reach from, for example, that's the starting point, and it goes to the top one here, which is A here. All right, so let's just draw a diagram here. So we've got a particle, it's project vertically upwards, and the position here is t equal to 0, velocity is equal to u. There is a force that goes up. Obviously we have two things that goes down. First one is the gravitational force, mg. The second one is the resistance, okay? And the resistance here is kV square. All right? Okay, it's not equal to mkV square in this case here. That only tells you that the resistive force is 1/10 of the square of its velocity. It doesn't mention anything about its mass. All right, so it's kV square. All right, just be careful about this one. All right, so first step here, we just need to write down the equation of motion. F is equal to, we've got two forces that goes down, so negative mg minus kV square. All right, then ma is equal to negative mg minus kV square, and then we can divide both sides by m, so a is equal to minus g minus kV square over m. That's the acceleration. All right, so once we have the acceleration, let's have a look at what the question requires us to do. We need to find the time for the particle reach from, reach A from O. So that's the time, and the highest point is equal to A, which means the velocity is equal to 0. So we want the VT equation, okay? So in this case here, we want to change this one and change this equation to the VT equation, all right? So let's start. So we need to find a way to change that into the velocity and time function. All right, so we have the acceleration is equal to minus g minus k v squared over m. We can, let's just substitute everything we have, right? And let's change that a into dv over dt. G is minus 10, G is 10, so that becomes minus 10, minus k is 1 over 10. V square over m. What does m equals to? M is equal to 10 kilograms. So that's also 10 here. Okay, once we have this, then the next step is we just need to integrate to the reciprocal. All right, but first let's just simplify the expression here first. So minus 10 minus v square over 100. Okay, then the next step is we need to combine the two combine the two fractions together, so that gives you minus 1,000 minus v squared over 100. Okay, so that should work. All right, so therefore now dt over dv, you do the reciprocal, so dt over dv is equal to 100 over minus, let's put a bracket, 1,000 plus v squared. All right, let's do that. And we can just move the minus to the front. All right, so now we can integrate. But then this time I'm just going to show you another method. In the previous example, I showed you guys, like, in order for you to find the time, we just normally integrate this, like we're, here. We integrate this one here, this function dv, and we're going to have, the result and plus c. Then after that we substitute the values inside, and when t equal to 0, v0 is equal to u, then we actually calculate what c equals to. And once we have the c, we substitute the c back. Then we substitute when v equals to 0, what is the time equals to. That's the way, that's the usual process to do the question. But there's another sort of like a way to do this question here without the need of finding c. Okay, because remember, c is a constant. The way to find a c here, eventually the c is going to be cancelled out, right? There's no need to find a c after you substitute the value here. So that we have a kind of a shortcut without using this method to get the results. Okay, so I would like to show you here. All right, so the way to do that is we use the property of definite integrals. Okay, so let's just move the dv to the other side. dv. All right, and then we integrate both sides here like this. Still pretty like standard. We integrate both sides. Then the most important thing here is we need to start to put the definite integrals there. Okay, and when you put the definite integrals, the idea is actually pretty clear. So say, for example, you put the sort of the lower one, the lower boundary, as a 0, which means that's the initial time. So I'm just showing you, this is the initial time, or the starting time. Okay, and the starting time, the velocity is actually equals to u, so you can put a u here. All right, so this is sort of matching. All right, this is all on the bottom. Okay, the lower boundaries. So this is the initial time, and the initial velocity is equal to u. All right, then we need to find the time. So we'll put a time here for the particle to reach the velocity equals to 0. Okay, so this is the time we want. Okay, and this is when a velocity equals to 0, which means the maximum, position, or maximum, height. Velocity equals to 0. All right, so if you have this expression, so we don't need to use, to find the value of c if we do it this way. And this sort of like save your time if you know how to use this method properly. Okay, so you don't have to actually find the value of c and substitute the c back into the expression in order for you to actually calculate the value. All right, so once you have this, we can just now integrate both sides, and we can substitute the values inside. All right, so on the left-hand side is actually pretty easy. It's just equals to t is equal to. On the right-hand side, what I want to do is try to get rid of the minus. All right, so we can switch these two around after I get rid of the minus. So this is what we can do here. Now, so that becomes a u, and that's equal to 0. And that's 100 over v squared plus 1,000. All right, and dv. So that shouldn't be very hard to do. Okay, it's actually pretty easy. Okay, so once this is done, now what is this about? Okay, so this is the inverse tangent, integration here. All right, inverse tangent. So let's do that. So that's 100 over v squared plus the square root of 1,000 and square dv. Okay, so you do need to change that into the square root of 1,000, just because you want to use the formula v squared plus a squared, that formula here. Okay, I hope you still remember that. All right, that shouldn't be a problem. Okay, all right, now with the square root of 1,000, if you simplify this, square root of 1,000 is just equals to 10 square root of 10. Okay, 10 square root of 10. All right, so then in that case, we can also move the 100 outside, and then we can start to integrate. Okay, all right. So what's the answer equals to? That is equal to 100 times by its inverse tangent, so that is 1 over, okay, 10 square root of 10, tangent inverse v over 10 square root of 10, okay, and then we need to integrate from 0 to u. Alright, so once we simplify this one, the 110 cancels out, that becomes 10, so 10 over square root of 10, tangent inverse v over 10 square root of 10. And you can just substitute u and 0 inside. Okay, 10 square root of 10, 10 over square root of 10 is just equal to square root of 10. Okay, pretty sure, because you can times both the top and the bottom by square root of 10, and then those cancels out. Okay. Tangent inverse u over 10 square root of 10 minus tangent inverse 0, 10 square root of 10. Okay, so obviously this part is equal to 0, so the final answer will be square root of 10 tangent inverse u over 10 square root of 10. Okay, so let's have a look whether this is the answer. Yep, that is the answer to this question here. Alright, so I just showed a way that you don't need to find the value of c, and you can still integrate both sides to find, to actually solve the question. I feel like, in the future examples, I'm just going to use this method to show you, how to do the question instead of finding the value of c. Alright, so the next question here, question B, you need to show that the height OA is that. Okay, the height, the actual maximum height when the velocity is equal to 0. So in that case here, we're looking for instead of VT equations here, we're looking at Vx equation. Okay, the Vx equation. All right, so, and then we let V equal to 0 to find the value of x. All right, so this is very similar to the previous question now. Okay, all right, let's just start. I'm just going to use this again. That's our equation motion. Okay, and we want to find the maximum height. So we're going to change this one into v dv over dx. That's minus g minus kv squared over m. Okay, all right. So dv over dx is minus g over v minus kv over m. All right. Okay, you can substitute the value of k, m, and g and everything inside. I feel like, it's better, probably just, easier to do it without substitution first. So minus mg minus kv squared over mv dv over dx. Okay, I hope my algebra is correct. All right, so once this is done, actually that's a plus. Now you can do the reciprocal. Both sides of dx over dv is minus mv over kv squared plus gm. Okay. All right, so let's integrate. We want to find the maximum height, right? So in this case, we can do the same thing. So minus mv over kv squared plus gm dv. So we can integrate both sides and put the boundaries we need. All right. So that way we don't have to actually calculate what is the value of c. All right, so let's put the boundaries inside. So initial position is 0, all right? Remember the particle actually starts from the ground, okay, goes up. So initially that, distance here is equal to 0. And that distance here is the highest point, which I don't know, so we can just say that's x. And at this distance here, the velocity is equal to 0. Okay. Oh, no, the velocity is equal to u, sorry. The initial velocity at this point is u. However, the velocity is equal to 0 up there. So that's u, that's 0 up here. Okay. All right, so that's about it. Now I can just integrate both sides. That gives you x on the left-hand side. On the right-hand side, I can switch them around, remove the negative. Okay. All right. All right, so this is just a pretty easy integration. The derivative of the denominator is 2kv, so that means I need to have 2k negative over 2k in the front. Okay. All right, so the answer here, I'm just going to write here, is m over 2k ln absolute value kv squared plus gm. All right, now remember you need to integrate from 0 to u. All right, so I'm guessing now I can just put everything inside. The m, the mass is equal to 10. K is equal to 1 over 10, so which is 5. All right. Oh, no. That's not right. 2 times by 1 over 10 is not 5. It's 1 over 5. Okay. Ln K is 1 over 10. Velocity is equal to u squared now. All right, because you're substituting this u into here. All right. Plus g is 10. And m is 10. Okay. Minus. Now you need to substitute 0 inside. Just be careful when you substitute 0 inside, it does not always disappear what's inside. So when you put a 0 inside v here, that part disappears. However, you still have gm, which is equal to 100. So that gives you ln 100. Okay, I hope that's right. All right, so that's 50 ln absolute value 1 over 10 u squared plus 100, okay, minus ln 100. So that becomes 50 ln, let's do division, 1 over 10 u squared plus 100 divided by 100. Okay, and all we have to do now is get rid of the 1/10 on the numerator, so we times everything by 10. Okay, so that part disappeared. We just need to add a 0 here and a 0 there, and that becomes the answer. That is the maximum height. Okay, let's see if that's the right answer. That is the maximum height here. All right, good. So we've got a maximum height. All right, now question 6c, which is slightly harder, I think. Now, let w be the velocity of the particle when it returns to u, and show that w squared is equal to that. All right, so this time we have the particle that's actually falling downwards. All right, so the particle reaches the highest point first and then it goes down. So now we need to show that the w squared is equal to that expression there. But w is just the velocity of the particle when it returns to 0. Okay, from the highest point now, return to 0, and then the question asks you to find out what w squared equals to. Okay, all right, so let's start. Same thing, I need to copy this one down first, and then I need to make some changes to that expression here before we can do the question. Let's do that. All right, so question C. All right, so if you look at this expression here, this is the expression for going up, right? The particle that moving up. But now the particle is actually moving downwards. So therefore, the gravity is mg, which is the same motion here. The force is the same motion going downwards. Gravity is going down as well. However, the resistance is going up, all right? So therefore, we just need to remove the negative in the front here. That's all we need to do, okay, at a moment, all right? And the expression itself is still remain the same. All right, so the object falls at the distance of OA. Okay, so the total distance here right now, if you draw a nice diagram, the total distance here is just equals to OA, which is from the previous answer. We have that 50 ln u squared plus 1,000 over 1,000. Okay, that's the OA. We need to use that later. All right, so in this case here, we need to find the velocity at this point, okay, w. We need to know what w is equal to at this point. So what we need to do is we need the Vx equation from here. So velocity and displacement equation. So v dv over dx is equal to g minus kv squared over m. All right, so it's the usual process like previously. All right, so get to this point, and then we need to integrate, okay? Right, so dv over dx gm minus kv squared over mv, dx over dv is mv over gm minus kv squared. Okay, so if we want to integrate this, we can use the method that we just did before as well. So x is equal to, so we can integrate x, integrate dx is equal to integrate mv over gm minus kv squared dv. All right, let's put our boundary conditions inside. All right, firstly, when x is equal to 0, when x equal to 0, velocity is equal to 0. So at this point now, x equal to 0, velocity is equal to 0. That's the first thing you need to sort of know, right? Okay, so when x is equal to 0, velocity is equal to 0. When x is equal to the distance here, which is the distance here, then the next thing you need to think about is, hey, if x is equal to that much, what does w equals to? All right, so that's the idea, okay? All right, so when x is equal to the total distance, which is OA, then that is equal to w. All right, so the velocity is equal to w. That is the value of x, and we're treating x as the original position of the, of the object. Okay. So now we can integrate it. So that gives us like OA, which is just x. I just don't have time to put this one inside. Is equal to, we need to integrate this one here on this side. So that becomes, m. What's the best way to do that? I'll probably just do it step by step. All right, so the derivative of the denominator is negative 2k, so I need to have negative 2k here, okay, and outside I need to have a negative 2k as well. All right, so once this is done, then the next step here is we need to integrate. Okay, so that's minus m over 2k ln gm minus kv squared. And you're integrating from 0 to w. Okay, all right, and then we've got OA, which is on the left hand side. OA is 50 ln u squared plus 1,000 over 1,000 is equal to. Oh well, okay. Let's hope I can get the right answer there. All right, so it's minus m over 2k ln gm minus kw squared minus ln gm. Okay, all right, so let's put all the information we have. I've got an extra 0. All right, m is equal to 10. That is 2 times by 1 over 10. Gm is equal to 100 minus 1 over 10 w squared minus ln, that's 100. Okay, all right. So that becomes negative 50 ln 100 minus 1 over 10 w squared over 100. Okay. Did I miss anything? Yes, I missed the 50 here. All right. Okay, almost done. All right, now I can just cancel the 50 with negative 50. We do have a remaining negative inside, which I can put negative inside here, do the reciprocal. So that gives us ln u squared plus 1,000 over 1,000 is equal to ln 100 over 100 minus 1 over 10 w squared. All right, now since both sides is equal to ln, so we can just remove the ln and equating what's inside. All right, and then at the end we just need to make sure that w squared is the subject, so we need to rearrange it. All right. Okay. All right. Let's hope I'm getting the right answer. Okay. Sorry. All right. Let's continue. So cross multiplication here. Is that the best way of doing it? Okay. Anyway, don't have much choice here. Cross multiply. Alright, and we need to expand. Okay, we can cancel these two out. Factorize the w square out. W square is equal to 1,000 u square over u square plus 1,000. Okay, let's check if that's the right answer. 1,000 u square over u square plus 1,000. Yes, that's what a w is equal to. All right, pretty crazy, that question at the end. So this is an example of a combination, like as you can see, a combination of a motion that's going up and going downwards. Okay, all right. So this is just the second part. I'll just use the second one question to go through the second part of this vertical resistor motion, and there will be a third part and fourth part to this lesson. Okay, I hope you understand what's going on. Thanks for watching.